My paper title is Analysis of Transmission and Reflection Paths on Metal and Semiconductor Interface with PML and MUR Boundary Condition for Carrier Dynamic Effect. This paper mainly emphasizes the analysis of transmission and reflection. Research program in this study is the carrier dynamic on metal semiconductor interface for high performance semiconductor device. Research solution is to make the software model with FDTD solution for transmission and reflection paths on metal semiconductor interface with the help of MATLAB. Outline of today my presentation include 5 articles. They are introduction, FDTD algorithm, implementation, my research and discussion, and finally conclusion of my presentation. Now I introduce you about the role of charge carrier. The charge carrier in semiconductor. For the beginning for a variation of significant technology together with computer, semiconductor laser, and light emitting device. Charge carrier can obligate precise diverse property in semiconductor and semiconductor nanostructure, certain on morphology, temperature, and material properties such as the crystal structure, pancake, dielectric function, and electron phonon coupling strength. Mechanic effect based on carrier dynamic consideration are vital to enhance the fabrication of high performance device. This is the FDTD algorithm for magnetic field. The first 3 equation is for magnetic field, and the last 3 equation is for electric field. We implement the flowchart for reflection paths on MUR and PML boundary condition, and also the flowchart for transmission paths on these 2 boundary conditions. This is the flowchart, reflection analysis flowchart for MUR and absorbing boundary. Firstly, we set for MUR and PML, and then we set the current factor, and then we declare the free parameter, permittivity epsilon naught, permeability mu naught, speed of light c, and wavelength lambda. For electric field and magnetic field set to 0 for initialization, and also declare the specific time step. In the next step, we set the physical parameter for metal and semiconductor, such as refractive index and thickness. And then we specify the FDTD algorithm for reflection. Then we calculate the for MUR or PML. Finally, we get the reflection path between metal and semiconductor phase. The next flowchart is the transmission analysis for PML and MUR boundary condition. It also the same from step 1 with reflection. Step 5, we specify the FDTD algorithm for transmission. In step 6, we calculate the boundary condition for MUR or PML. And then we get the transmission path between metal and semiconductor interface. For analysis result of reflection and transmission paths for MUR and PML boundary condition will show in the next slide. This result shows the reflection signal with MUR absorbing boundary condition. Light is incident on interface of metal and semiconductor. Using this MUR boundary condition, we can see the center of reflection about 250 micron, and also detect the reflected signal about 400 micron scale. This result shows the reflection signal with PML boundary condition. Light source is incident on metal and semiconductor interface. Using this PML boundary condition, we can see the center of reflection about 225 micron, and also detect the reflection signal about 350 micron scale. PML boundary condition can only detect the sharp reflected signal than MUR absorbing boundary condition. In this result figure, the transmission path at metal and semiconductor interface with MUR absorbing boundary condition. We can see the transmission center about 180 micron scale. So we can detect the transmitter signal about 350 micron scale. This result is the transmission path with PML boundary condition. We can see the center of transmission about 160 micron, and then we can detect the transmitter signal about 300 micron. Let me conclude my presentation. Numerical analysis on metal and semiconductor interface with MUR and PML boundary accomplished based on FDTD algorithm for carrier dynamic effect. For analysis with reflection and transmission paths with PML and MUR for interface quantum mechanics for high performance semiconductor device fabrication. Result on different model of MUR and PML boundary condition. FDTD analysis confirmed that high performance condition for carrier effect in metal and semiconductor interface. Thank you very much for your attention.